Good morning, or good evening, and welcome everyone to today's webinar on securing your web applications in an AWS environment. Before we start, a couple of housekeeping items. You will notice we are using the GoToWebinar viewer today. If you look at your control panel, the little orange panel will let you expand and hide that. This is where you can choose on how to listen to us today, either via microphone or speaker or the telephone. You will all have joined us in listen-only mode. That means you're muted to cut back on the background noise, but that doesn't mean we don't want to hear from you. Feel free to chat with us and drop any questions via the Q&A or chat window, and we will address them during the Q&A session of the webinar. The webinar recording will be sent to all webinar participants post the event. We have Pat McDowell, Security Solutions Architect, Amazon Web Services, Venkatesh Sundar, or Venki as he's like to be called, Chief Marketing Officer at Indusface, and Karthik Krishnamurthy, Head of Engineering at Indusface. My name is Nikhil Desa, and I'm here with you from the team of Indusface, and I'm here to help monitor the questions during the Q&A.
So what will we cover today? So the security at AWS public cloud provides, how to secure your websites hosted in the AWS cloud, and to watch a security expert perform a layer 7 DDoS attack in real time. So with this said, I'm going to hand it over to Pat, and Pat, you can go ahead and get started with the presentation today.
Thanks so much. You know, cloud is quickly becoming the new normal. And for enterprises, the question isn't if they should go to the public cloud, it's really just how fast can we move and what are we going to move first? We've seen a real inflection point over the last 6 to 12 months of enterprise adoption, and especially in some industries that are slower to adopt. In such industries of oil and gas, we have customers like Shell and BP and Hess. In financial services, we have FINRA, Intuit, Suncorp, the Commonwealth Bank of Australia. And in healthcare, we have customers like Johnson & Johnson, Pfizer, Bristol-Myers Squibb, and Merck. Also in the communications industry, we have Vodafone, Comcast, and NTT Docomo. And in the media space, we have Condé Nast, the Dow Jones, and New York Times. Almost every imaginable business segment is using AWS in a very meaningful way. The cloud is such a strong value proposition for customers that there really isn't a customer segment that won't get a lot of benefit from moving to the cloud. And as you can see here are some of the key reasons why enterprises move to the cloud. It's agile. It enables their developers. Their security posture is increased. Within seconds, they can deploy globally. We have all those regions around the world. The pricing is elastic. And at AWS, security is always our #1 priority. And in order to one of the key takeaways about security is that we have a shared responsibility model with the customer. AWS manages and controls the components from the host operating system and virtualization layer down to the physical security of the facilities in which the services operate. And AWS customers are responsible for building and securing their own applications. AWS provides a wide variety of best practice documents, encryption tools, and other guidance that customers can leverage to deliver these application security measures. In addition, AWS partners like Indusface offer products and features to help customers meet their security objectives. The shared responsibility model follows the premise that you cannot deploy secure applications by yourself because you have to rely on us, Amazon Web Services, and we cannot secure things for you because we do not have access into your EC2 instances. It takes AWS and our partners and our customers working together to create a truly secure environment. But customers have the ability to choose such things as what encryption to use and how to patch your operating systems. We refer to our side of the shared security model of security of the cloud. And on the customer side, it's described as security in or on the cloud. So we have a whole list of certifications and accreditations. Almost any certification or accreditation you can think of, we have. Some of these include third-party assurance frameworks such as ISO 20001, PCI for payment cards, SOC 1, 2, and 3, HIPAA, FedRAMP for our U.S. government customers, and as well as DoD systems. However, we are constantly listening to customers and are looking into other certifications for the future. We also have ISO 9007-01, which is for healthcare, and all this is available to you, the customers, under NDA for your own review. The important thing to understand is just because, for example, if you're running a PCI application in AWS, that does not make you automatically PCI compliant. That is a joint effort of that shared responsibility model we just discussed. So what needs to be done to keep systems safe? And this goes back to the shared responsibility model. This is everything what we do, large thing, and what the customers have to do. So patching your operating systems, for example, making sure user access is defined properly, and then disabling user accounts when they leave the company. What AWS does, for instance, the physical security of our data centers. If you go over here, we have currently, I believe, 34 availability zones around the globe. We just launched our latest Ohio region in the United States, US East 2. And these buildings, no one knows the addresses to them. They're physical security controls. It's ticketed access only. Separation of duties is keys here. We like to say if someone can touch metal, they have no logical or computer access privileges to your data either. But the cloud itself, and specifically AWS, greatly increases your visibility and auditability and control of your network and data and customer content. In terms of visibility, everyone has heard the example of, well, you don't know what's plugged in under someone's desk, who's plugging into things. Since everything's an API call away, you can literally, this reminds me of my data centers days, with a single API call, there's no such thing as where does this Ethernet cable go? You know exactly and within seconds of what is running in your system altogether. This is a great example of our console, and you can see everything's running. There's no mystery boxes plugged in under someone's desk. Now, a great feature that is for free, and the feature set gets richer depending on your support tier, is Trusted Advisor. Amazon Web Services will tell you, if, for instance, you have wide open firewall rules. But I think the greatest thing is, we'll tell you if you're spending too much money in terms of cost optimization. We always want to pass savings to our customers and want to tell them how to save more money. So we will actually provide this information to you in our Trusted Advisor, which is free to use at start. And as you get more and more Trusted Advisor checks, which is tied to your support level, you get even more information. There's also more auditability that comes into the cloud by default. As you can see here, the CTO of NASA's Jet Propulsion Laboratory, who used to build his own data centers, now fully believes he can run even more secure in the AWS cloud, which is a huge value prop. NASA Jet Propulsion Laboratory obviously has lots and lots of sensitive data, and they are a great customer of ours. AWS CloudTrail. So everything in AWS is an API call. It doesn't matter if you're copying a disk volume or you're simply attaching a network interface. All that information is going to be constantly recorded into logs. You have complete visibility into who's doing what in your environment, and everything is recorded, which is a huge gain for security. You could just collect all that data historically, pump it into your log collection tool of choice, and search that data. So you could tell if a privileged user did something at an unknown hour, what they did, what service they called, and what technique did they. So some things are very, like read-only API calls, describe calls, are very mundane, but say attach internet gateway might be something you want to alert on. And as you see, this is how CloudTrail works. It's across all of our services, and it's constantly recorded and continuously monitored 24/7. And all that data is available to you. Now, in terms of control, the cloud gives you more control and tells you who has those controls. And the great thing, this comes under our AWS Identity and Access Management tool. You can make these policies as granular as you want. You can say, this set of person only has access to these accounting applications, and only on this certain operating system, for example. You can base that off your AMI and make these policies super granular and really give you even more granular controls than you can ever have on premises. And being in the public cloud, data encryption is a huge, huge concern for our customers. And we wanted to make sure we make it as easy as possible to encrypt your data. And we provide you a wide variety of texts to do that. You could use our server-side encryption, but since everything is application-based, you, the users, always have the ability to encrypt client-side and before you put your data on us. One of the best services, in my opinion, that we offer is AWS KMS, our key management service. It's really literally checkbox encryption with keys that you control and keys that live in hardened security appliances. So you control the lifecycle of your key, who has access to the key, when you do it, and when you launch a new instance, you literally click encrypt this volume, as you can see right here, and then your data is encrypted with keys of your choosing in a secure, hardened appliance, which integrates seamlessly with such services as our EBS, which is our block storage, and also Amazon S3, which is our object storage. In addition to KMS, we have our Cloud HSM, which are FIPS 142 Level 2 validated key HSMs, hardware security modules. And they live directly in the AWS cloud, so it's low latency connection to you. And these are actually based on the SafeNet Multi-Luna platform, so it's the same APIs maybe you're used to already using on premises. So you can have the same encryption story that you have on premises is in the cloud also, as another alternative to Amazon's KMS. So the cloud's giving you more visibility, more availability, and more control. And I hope you guys, I know I ran through a lot of things really fast right there, but I believe there was a lot of knowledge, and I hope you can see how your security posture actually improves as you move to the cloud. And you look at all the enterprise customers who have moved to the cloud for security alone. Thanks.
All right. Thanks, Pat. That was sort of reinforcing, and not just reinforcing in PowerPoint format, that I have lived through this experience with our joint customers who are using our products and solutions built on AWS for AWS customers. So before I start getting into my part of the presentation, a quick check for Nikhil or Pat. Can you see my screen?
Yep, we can see your screen.
All right. So Indusface is an application security company built on AWS for AWS customers. And one of the key things that we find about customers on AWS, why they move to AWS or choose AWS as their platform for public cloud and hosting their applications, is agility and speed, which Pat already talked about, right? And what do they put on AWS, right? We have AWS provides infrastructure as a service, and what they put on the infrastructure central to it is applications and services, which is needed for running their business, right? And customers or businesses which value speed, obviously they do that because they want to focus on scaling their business. They have reached a certain point in time, they value speed because they have aspirations to grow and focus on what they do best. And with this, AWS is taking the challenge or problem of figuring out the infrastructure and data center management away from the customer. The other thing that comes in the way of speed is security. Customers who are in AWS and value speed always are concerned about security and what they do about it, right? And anything that comes in the way of speed is a problem for them. And we come in there and help address that, taking the same philosophy that AWS takes at an application security layer, to take that pain away from them and let them have their agility. So we are a one-stop shop to fix all your application security issues. And we do that through a use case driven approach where for your application, we will detect what is your current risks. We will protect them immediately and will continuously monitor them. And this has worked like magic and amazingly well with some of the traditional, he talked about oil and gas in India and Asia, which is where we have a lot of customer references now, BFSI segment, e-commerce segment, new startups which are trying to get acceleration, SaaS companies where security is a concern for them. They come to us They are hosted on AWS, and take the detect, protect, monitor offering from us for their application security and get the one-stop shop to fix all security issues from us. So I'll take about 15 minutes. It's going to be a lot of information in a very short period of time. So it's going to be an information overload. So there's only so much I can say in this short period. So if you want to get into details, you can always go to our website and look at our blogs, research blogs, and white papers, and download those papers. Right? So you can take those themes and get into more details on those aspects I'll be talking about or giving a brief about right now. All right. So public cloud, essential to more than cost benefits. The real, as I told you, it's really about speed, right? And Pat already talked about shared responsibility, right? Anything at the network or below the hypervisor level, and physical security is the responsibility of the of AWS. Anything above it, which will include applications, also include applications, is the responsibility of the customer, right? And your application is built for servicing your customers or your business, either for doing transactions or for enhancing your brand. The customers who are there are focused on providing more enriched capabilities in this area. But for security, you can partner with Indusface, and we take that responsibility and allow you to focus on your business, and we focus on providing a complete product managed offering, application security solution. How do we do that? We do that through the use cases I talked about: detect, protect, and monitor. And we're going to double click on each of those use cases and talk about the challenges and what has to be done to address those challenges. Right. So detection challenges. No application is an island, right? Especially in this day and age of web services and open architectures and collaborations with multiple units. Simplicity to your customer is the goal, but behind that simplicity, there is a lot of best of breed solutions that are stitched together and orchestrated and providing the value proposition to the customer. So there are many moving parts, right? So web applications are not an island. They are critical to the business. And with criticality comes risks, and that is security risks. Now, the first aspect of that addressing that is you have to know what is my risk. And with so many moving parts, it's not something that you can do one time and forget about it and address those risks. You have to do it continuously. And not just continuously, you have to do it in depth, right? So web application, many moving parts, changing continuously. The cliche in this space is your strongest defense is only as strong as your weakest link, right? So with this many moving parts, even a single weakest link, which may not be an application component you own, can be a third-party payment gateway or a vulnerability on that, or a vulnerability on the web server or the framework on which you are running your application, that can cause significant threats. So you have to first at least know about those threats before you can at least act on that, right? And you have to do it frequently and continuously. On top of this, there are business logic flaws which are tough to find, but the risk for those business logic flaws are very, very high. If the risk of an exploit or the impact of an exploit. What I mean by that is an application which is a document management system. Somebody logs in as webkey but can access fax document. It's a business logic. Or if it's a banking application, I'm able to open an account and put some money into it, which are actually putting the money, flow of money. And the logic around the flow of money is a business logic. E-commerce applications, buying something without paying the money, right? So depending on the context of the application, the business logic and the logic that is used in the application to do it has some vulnerabilities, can be exploited to do some serious damage, right? So these are all the aspects in an application and the complexities and challenges. How do we address them? What we need to do is we need to do a comprehensive application testing, which it's not a tool that you run and forget about it. You have to do automated plus manual approach. You need to do things frequently to at least have the base level of detection and risk identified on a continuous basis based on standards like Open Web Application, OWASP, and do in-depth manual penetration testing periodically, once a quarter, once a year, to do the business logic checks. And combination of automated and human intelligence will help you get a comprehensive application testing. So at least you get to know what is my current risks. Think about it like a hacker. It's not like a hacker is going to shoot things in the dark, right? They are also going to be doing the same thing. Before they do a fraud or try to do some, they will try to find what is a weak spot, what is a vulnerability. They will run automated scanners, find a vulnerability, and then it's much easier for them to do a targeted attack, exploiting those vulnerabilities. Right? The intent is the difference is in intent. They use tools, they do detect, we do detect, but they exploit, we report, and help you at least take actions on that. Right? So you need comprehensive, and we just don't stop it with a tool level. Also do business logic testing with manual pen testing. Now, now that at the end of this, you have an identification of continuously what is my security posture and risks, what are my hackable, exploitable risks in the application. What do we do about it? Okay, of course you have to fix it. We put a snapshot and put a magnifying lens showing you these are all your risks and these are all how you'll be impacted. Business logic flaws or any other web application security flaws that can be exploited by hacker. But fixing is not easy. Detection alone is not enough. And fixing, even if the intent is there, here's a piece of statistics I have from the 3,000 plus web applications that we scan on a continuous basis. 8 in 10 critical vulnerabilities take close to 6 months after they're identified for them to even fix it at an application level. 9 in 10 takes close to 4 months. So patching a web application, even if the intent is there, going back to the point I mentioned that no application is an island, they interact with many components. It's quite possible that the component where there is a vulnerability may not even be owned by the business which is using it, right? So that's one aspect. The other aspect is your own dev cycles and priorities. It might take some time to fix it. So patching it in a timely manner is not as easy, even if the intent is there. So time to fix is certainly one key reason, but not the only reason. I will talk about it a little bit more later, right? And you might ask that, okay, how are people going to, I have a network firewall, I have perimeters and security in place, but web applications by design is meant to be open for the world, right? So even though you might have network firewalls and other things in place, port 80 and port 443 is open generally, and somebody can directly access the application, and a legitimate user can get in, and an attacker can get in, pretending to be looking like a legitimate user and carry out do some damage, right? 75% of the attacks are carried out at the application layer as per Gartner. It takes more than 100 days to fix a vulnerability after it is known. Unlike network firewall solutions, at an application layer, a security solution cannot be a cookie cutter that you configure and forget about it and have some protection. It has to be managed. Security as a service is going to be the key aspect of any kind of web application protection technology. WAF is the lingo that has been there for quite some time, right? 451 says that expert tuning is the difference between a working difference layer for application as opposed to something that is gathering dust, right? So and application DDoS is a big risk. Application DDoS is not really targeting any vulnerability, but it can, with very minimal computing power, with very minimal technical skills, can really bring down your application. I mean, why would somebody do that? The answer is ransomware. And I have case studies of our customers who have been subjected to this, and they needed protection. Application layer DDoS is a big headache, and ransomware, it's one of the key things that is used for ransomware. Telling the customer that we'll take you down if you don't pay us this much amount of money by so and so date. Big headache, right? So application security needs a very specialized, focused approach. It's not something that you, like a network firewall, you have IP rules, whitelisting and blacklisting, and have it working. That is the approach I unfortunately feel is the view in the industry. I have terms like next generation firewalls that I see being thrown in the industry, and it's not really next generation firewall. It is like slapping in a bunch of layer 7 rules on an existing load balancer or anything that is in the path and call it a next generation firewall. Sorry, putting in a rule and having a bunch of policies is a real easy part of the entire thing. What should that policy be? How would that policy keep itself updated? How does it have, the policy itself has to be more dynamic. So I would think that people should be talking about next generation application security as opposed to just calling it next generation firewall with WAF thrown into it. WAF as web application security is a specialized field, and in that you can do a lot more advanced things, and we should be evolving towards next generation application security solution. In fact, I want to eliminate the term firewall. Customers care about application security. Firewall is a technical mumbo jumbo underneath it that solves the problem. How does it solve the problem? What are the use cases? How do I combine? What is my risk? How do I protect myself against those risks? How do I keep myself up to date to make sure that my defense is always strong and one step ahead of the attackers? And that's where I'm going to come into the monitoring. Going back to the point I mentioned, so I'm just going to pause here for a second. This is the most powerful part of the value proposition. I mentioned that once you find a vulnerability, obviously the right place to fix it is in your application. Web application firewall or anything cannot be a replacement to a fix in the application, right? But in spite of that, I would say that there is a lot of value in having a web application firewall, having a policy to address those kind of attacks. Now, take a step back. I mentioned that an attacker is also doing the same thing. They are trying to find vulnerabilities, or they're trying to do application DDoS, and they are trying to do a targeted attack. Application DDoS is not really targeted, but a vulnerability-based attack can be targeted, trying to exploit the vulnerability. So once you have a vulnerability found in an application, there is a very high possibility that you will also have attackers who have found the same vulnerabilities and will be trying to send payloads to exploit that. Now, if you fix those vulnerabilities in your application, good thing. Of course, you have defense in depth and your application is not vulnerable. But an attempted attack attempt, which is more likely to have those vulnerable payloads that has been detected once upon a time, the insights of who did it, where they came from, why were they trying to do it, what all things else they tried after doing this is lost. And that is why an application layer security with protect layer, not only does it protect the time to fix, which is, I said, is just one aspect of the benefit, but not the only aspect. The bigger aspect is it creates an entry, an event is generated based on which you get insights on an attempted attack attempt. And that feeds into the monitoring. And a lot of intelligence can be gained from it. And the intelligence, I will start explaining how those things will play out. Because another point I mentioned was it's not a cookie cutter solution. I'm going to talk about an example where the policies can update itself based on events and violations that have been detected by the detect capabilities and protected and event generated by the protect feature. Right. So in monitor, not only do we need to look at events and everything, but I have to correlate it and find out, do an in-depth analysis to where it is coming from. What are the different types of payloads, categories, and take those steps back into feeding it back into your detect protect cycle to improve that. That in a nutshell is what is the monitoring. One is just looking at incident monitoring and looking at some insights and reports and giving you this. But taking those data and feeding those intelligence back into the system, detect, protect, monitor cycle, makes it very, very powerful. It requires a combination of automation plus human touch. Human touch is where we as an application security provider provides a complete managed solution. We will do the analysis and keep updating it. We also have automatic self-updates in place, which will provide the intelligent-based policy updates based on monitoring events. We also provide proof of evidences, proof of exploitations for all the automated stuff that we include in our solution. That's what collectively the automated plus monitor, the human touch in the monitor that we provide. I'm going to give you an example here, validate and further validate the point with an example here. Right. So the detect layer, I talked about define vulnerabilities. Okay. So let me walk you through the entire use case and finish it off with how monitoring feeds it back. Okay. So in the detect use case, let me say you have let me take a very simple web form, which has got, let's say, a mobile number as a form field, input field. And the user submits the mobile number and a bunch of other data and gets stored back in the database. Now, a mobile number form field will have a very simple data validation logic that it should only be digits. It cannot have alphanumeric characters. It should be 8 digits, 10 digits in length. Now, this validation logic of this form field, most of these customers or most of the websites we have worked with do the enforcement on the client side. If it's a mobile application, through some client-side validation, when they enter, they have a feedback, no, it has to be all digits, or through JavaScript. A normal user will go through it, ensure they enter the right mobile number and submit it. Now, you can bypass the client-side validation through tools like Burp Proxy or something, manipulate the parameter before it hits the server, and the server may not validate it again. So this detection, as per the OWASP standards, it's called as no server-side validation enforced. Now, you can choose to fix it in your application, which you should. Even if you fix it in your application, if we take this vulnerability and create a patch for it in the protect layer. Now, when this event in the protect layer and this policy gets hit, it's a guaranteed attacker on the other side. I repeat, when this policy gets hit, it's a guaranteed attacker on the other side because they have bypassed client-side validation and hence it's not a normal user. Now, this insight can feed back into the protect layer saying that what more can I get from this session? The IP address, the session ID, the user ID, all the data, and given that they have crossed the threshold of doubt between a normal user and a bad user, we know for a fact it's a bad user, the policy can become more dynamic. It's not a cookie cutter bang on static set of rules. To now say, now for this, based on this event, I start blocking them completely and be more aggressive in my block rules. That's monitoring and update in action, right? Application DDoS. I cannot have a single application DDoS rule for customer X and customer Y or web application X and Y. One of the most common is CAPTCHA with rate control, right? But what will be the attributes of rate control can be different. Monitoring will help you determine that and feed that back into coming up with a more appropriate application DDoS protection. Now, if you take a step forward and take a look at what is going to happen, proactive learning with analytics, self-learning, translating into predictive analytics and prescriptive analytics and protection with machine learning, and of course with human touch on top of it is going to be extremely powerful. And that is what we mean by a complete managed solution, which next generation firewall, which is just slapping in a bunch of policy. And by the way, they don't even tell you those policy, you apply those policy, you apply your brain and do it. And customers don't have the time to figure it out. It's the language and the policies are not simple X is equal to Y and X not equal to Y kind of rules. There is a logic in that. It has to be managed. And customers where speed is of essence, will they focus on developing their applications and evolving it, or focus time learning this and maintaining this? That's where the gap exists. And by providing this package together in one solution and in AWS, where speed is of essence for AWS customer, and as we evolve, putting machine learning, predictive analytics and all this, it becomes extremely powerful, right? And that's in a nutshell what we offer, and we mean by detect, protect, and monitor. And in fact, top of the headache right now, especially with ransomware, is application DDoS. I talk to customers, of course, vulnerabilities is a big pain point, but application DDoS, any kid can do it. And they can actually hold ransom the company who are actually paying a few Bitcoins or a few dollars because they don't want to have even half a minute of half a hour of downtime, which is a big pain point. Of course, vulnerabilities and business logic vulnerabilities is also a pain point and can lead to more dangerous frauds. But you need a expert, best in breed experts who takes this headache off the customer, let them focus on business and manage it for them. So I think we get to the interesting part of the session. I must have mentioned application DDoS and ransomware. This was something that actually happened to one of our customers, and we helped them do this, protect them. and we felt it will be very powerful to take what we actually did in a live scenario and demonstrate it in this webinar. So with this, I'm just going to pass it on to Karthik. Karthik, all yours.
So, like Venki said, this is actually based on a real-life situation that happened with one of our customers, where their site was actually attacked using application DDoS for ransomware, and we protected the website, and they did not have to pay the ransomware, obviously, right? So the scenario that I'm going to be showing now is showing the website, which is open to the internet without any protection. Launch an attack. You'll see the site getting slower and slower, and pretty much becomes unusable after a point. And then we'll route the traffic through the Indusface task, which is our WAF, and that will block the DDoS, and the website will become functional again. Okay. So this is the website that we're looking at. Anybody who wants to this is a live website right now. So anybody who wants can actually follow along by launching this in the browser and seeing what happens as the DDoS starts. When you do that, what I'm going to be doing through the demo is pressing Control F5 to refresh without the browser cache. And in my case, of course, I have the developer toolbar open. So I monitor this thing, finish time, which is the time it takes the website to load. So I'm just running it again. So this took about 2 and a bit seconds. So generally, I see this website loading between 1.5 to 2.5 seconds, right? So, and it's functional and stuff. So let me go ahead and start the attack. So I'm going to be launching an application level DDoS on the site, which is pretty much going to send a lot of connections to the website, which is like a get flood. And just to make sure it happens a lot sooner, I'm actually going to launch it from 2 separate machines. So you can see the attacks are starting, a lot of requests are being sent, and let's go back and see how the website's reacting to this. So I'm going to start loading. Again, Control F5, refreshing. It's sometimes easier to see it if I launch another tab as well. You can see how long the website takes to load, right? If you're looking at how much the browser is spinning and stuff. Like in this case, it's already taking 16 seconds to load. You can see the images are kind of crawling and kind of loading. This page still hasn't finished loading, by the way. You see some images come through. So this took 25 seconds to load this time. And if I keep doing this, and we wait long enough, you'll start seeing broken links, you'll start seeing page not loading, you'll see all sorts of issues with the website, right? So you can see how regular users, legitimate users, are going to start finding problems with the website. Right. The key part of this ransomware here is that why is it so easy for them to actually ask ransom is because application level DDoS is actually a very asymmetric attack. By that, what I mean is that the attacker doesn't have to spend as much money launching the attack as the website would have to if they have to launch really big machines to handle all the traffic, right? So it is asymmetric. It's much easier for the attacker to launch the attacks than for anybody to defend it. Like you can see here, there's a broken link. So this one is spinning. It's taking a long time to load and stuff, right? So now I'm going to go ahead and route the traffic through the Indusface staff. So I go to the domain. I'll go to the site, and I will change the routing to make it go through our configured tasks already. Now, DNS propagation takes time. It's it might take 25-30 seconds to do it. In the meantime, the attacks are still going through. I haven't stopped the attacks. And let's see the website reacting and recovering, right? So I'll launch new tab like I was doing before. And you'll see it will gradually recover. Like in this case, it finished loading in 7 seconds. It's getting better. Some things didn't load. I'll refresh again. It's getting even faster. It came back to 2.3 seconds. And now if I keep opening tabs, you'll actually see that the website's actually back to full speed, functional, and the attacks are being blocked. Let me just show you one more thing while we're at it. I'll actually log into our portal and show you what we actually did here. Right? So let me quickly do that. So you'll see here, we already blocked about a bunch of DDoS attacks, primarily from the 2 IPs that I launched. I'll go to our Protect tab. Once again, you'll see the 2 IPs where I've been launching the attacks from is where the counts are the highest. If I look at the category, here's the denial of service. Bulk of the attack. These were, some of the real attacks happening because the site is live. This is where a bulk of the traffic got, bulk of the traffic was from, and that's where we actually blocked things.
So thank you, Pat, Venki, and Karthik for great insights. So we're just coming into our Q&A session here. So I have a few questions from a couple of the attendees here, and I just thought I'll take a couple of questions and address these questions to our speakers here. So this first question that I would want to take up is, and I think this would go to Venki, is you mentioned about business logic testing. So how do you provide protection against business logic vulnerabilities?
Yeah, good question. So business logic vulnerabilities are the toughest to find, and also there is no cookie cutter solution which an out-of-box solution can provide. I talked about application firewall or application security solution not being set of ready-made, set of configured, set of values. We have some out-of-box rules and policies, which is called as core rule sets and core policies. But anything which is detected and the vulnerabilities which are detected, which cannot be addressed through those core policies, as part of our managed offering, can be addressed through custom rule sets. And I will give you an example of a business logic vulnerability. I talked about a document management solution where I can log in as Venki, and I have a query parameter which says access document for PAC, or in a banking application where I download somebody's statement, where in the HTTP protocol there might be a query parameter which will have an ID of the document which I have to download it from. So the attack is basically a business logic exploit, where an authenticated user is manipulating the query parameter to access and guessing somebody else's document, and the server is not validating and doing the check that is the authenticated user and the document and the query ID belong to the same person. Because being an application layer reverse proxy, and knowing that exactly what is the URI, what is the payload, what is the exact situation through or detect where this vulnerability can be exploited, a custom rule can be created till the point of time it is fixed in the application, right? And that's how, through a combination as part of the managed services, through custom rules, we can address even business logic vulnerabilities as much as possible. Now, the customer can still fix it in their application, but going back to the monitoring point, if somebody has logged in as Venki and tried to manipulate the parameter to change the document ID of somebody else's, guaranteed attack, which can feed back into the monitoring example that I gave. That's how we address it. I hope that answers the question.
Yeah, thanks, Venki. And so I've got another few more questions here. I think this is another question that I think you would be the right person to answer. Is you spoke about monitoring updates. So you gave an example of vulnerability found but not patched, but there is visibility. So with regards to these monitoring updates, are they automatic or completely manual?
It's a combination. Like our policy itself is not a standard set of X equal to Y, Y is equal to C, not equal to this kind of policy, right? It has a logic in it. And that logic can automatically, dynamically change based on the risk. If I know that the other person is a guaranteed attacker, what information do I have about that person, and tied to the identity and the risk score of that identity in that session, it can dynamically update itself and provide a better defense. That is what we call as automated part of the monitoring. And with machine learning, with good data, bad data, label data, I think the possibilities of more things than automated is going to increase significantly going forward. The manual part, of course, in addition to this, through the portal and the reports, a human can look at it and also come up with manual updates and assessment to with custom rules, with policies based on and seeing significantly higher number of hits on the same attacks on different IPs on this. And by the way, not just this customer, we are also seeing this with other customers, based on which we can come up with our own manual update. And then those updates can get fed back into the automated cycle later. So it's a hybrid combination approach, which it's not just automated, it is automated plus manual, which is what makes it powerful.
Okay, thanks again, Venki. And just two more questions. This question was particularly with regards to the demo. So the attendee was, found the DDoS demo quite insightful. And the question was, can you tell what kind of rules or logic was used for protection? Or can you explain in detail how protection works?
So I can take that, or Karthik, do you want to take? I can take the question as well.
Yeah, Venki, you can take this question.
Yeah. So in this particular case, the application layer DDoS was a significant number of requests, HTTP GET flooding, which was bringing down a site. So the standard defense for this is based on a couple of things. One is the identity from which it is coming. The identity in this case is IP address. Second is the URI on which it is, in this case, the website itself was being hit. And third is the rate, number of requests per second, based on which an action can be taken. The action can be throw a captcha, block their identity for a few minutes, and the DDoS attack goes away. So this is what we call as rate control. And the variable attributes that I talked about in terms of what the rate is, the URI and the action can all be customized for different customers. And we can have an intermediary action, which is what I can throw a captcha page. We can do further intelligence on top of it in the captcha page itself, where it's actually a human who is doing it and not a bot, right? They might still we'll still be able to get some more information besides IP if it's an authenticated session or something. But if it's a bot that is doing it and it is automating and filling up all the forms, more than likely in the captcha page itself, it is going to fail multiple times within a short duration of time. And we can take that intelligence and further build on it. So in this case, it was a very simple HTTP GET flooding and rate control is the answer. But there are other kinds of DDoS, Solaris attacks, which is the opposite of throwing in multiple requests in a short period. It's trying to open one connection and keep it open for a long period of time and keep sending requests 1 byte at a time every second. And you do that a few times, the connection pool gets exhausted. So in those cases, the combination of what would be a right chunked encoding size and Solaris kind of patterns and reputation data with third-party sources will help in production. And the advantage we have as a managed offering is not only do we source information about reputation from known sources, but we also build our own reputation database. And when something is happening in customer X, is it also happening in other customers? And based on which we can take more quick actions.
Okay. Thank you again, Venki. So I want to thank the audience for all your questions. I know there are a couple of questions that have still been unanswered, and if you've missed answering any of your questions, we will make sure to reach out to you all post this webinar with your inquiries and queries for that matter. And so we also encourage you all to take a 14-day trial of our task solution. So for this, you can reach out to us at sales@indusface.com, or also you can visit our website, which is www.indusface.com, and you can also go. You'll get a lot of information over there with regards to our solutions, services, and our offerings over there. We've also, with this webinar, we've also, set up a quick poll, which will just help us evaluate how well this webinar went. And I would encourage you all to give us your valuable feedback on this webinar. So the poll lasts for about 10 seconds. So starting now, and yeah, you all can just feel free to give your feedback here. So I want to thanks Pat, Venki, and Karthik for your valuable insights, and I'm sure the audience also for taking your precious time to be at this webinar. And so see you all, take care, and have a great day ahead. Thank you. Thanks again.